Hello and welcome everyone to today's Tech Talk on starter logistics models for forecasting, scheduling, and routing. My name is Haley. I'm part of the Nextmove team here, and I will be your MC for today. Today's presenter is Ryan O'Neill, CTO at Nextmove, and he'll be covering quite a bit over the next 29 to 28 minutes. He'll first set the stage for the on-demand logistics models that we'll be covering today. He's then going to dive into a fairly fantastic optimization speed run that links all of these models together. And then finally, we'll save time for Q&A at the end. We encourage you to use the Q&A feature at the bottom of the Zoom UI there. So feel free to use that, or feel free to drop questions into the chat. If you do that, just make sure that you keep an eye on that host and panelist versus everyone toggle, just so that your message or question gets to the right audience. And with that, I'm actually going to disappear into the Zoom background and let Ryan take it away. Ryan, it's all yours.
Thanks, Haley, for the intro, and thank you all for coming and seeing our Tech Talk. We have, I think, a fun round of demos today. As Haley mentioned, it's a fairly short time frame, so we're going to be covering a lot. This will basically be a talk about 3 different models and the infrastructure that you need to run them. And these models are targeted at on-demand delivery platforms. So we have a forecasting model, a scheduling model, and a routing model that we'll be going through. So in today's example, we'll be pretending to be employees of the farm share company, where we deliver farm-based goods to farm goods enthusiasts or carrot enthusiasts. When we're probably starting with some sort of a manual siloed process, and we're moving to some sort of automation. So that's the context here. The different kinds of models that we'll be solving are the necessary models, sort of the 3 critical ones that you'd need to do in order to automate your operations: forecasting demand, scheduling of drivers or couriers, and daily route planning. The Nextmove platform is the infrastructure part of this, and it sort of sits right in the middle of all of this. So we have data inputs and operational outputs, and the platform that we're going to be using that unifies all of these things, in which we can forecast, schedule, or route, is the Nextmove Decision Ops platform. So you'll see a little bit of that too. So we'll both be looking at models, use cases, and platform. In that platform, we are going to be looking at models built using our own internal solvers for routing, the Hy's mixed integer programming solver, as well as Google's OR tools. And we'll be using Python and Go code. So that's a little bit about what to expect there. So as Haley mentioned, we've only got, I think, probably now 26 minutes. And so this is a talk of breadth, not depth. So we're going to go across a wide swath of different things. And there's sort of 2 things that I'd like to demonstrate. The first thing I would like to demonstrate to you, one is just, let's say you're operating this kind of a business or this kind of operations. What are the 3 critical components? What are the 3 critical starter models that you need to use to automate your operations? What does data look like that go into those models, and how do they interact in production environments? The second one that I'd like to, the thing I'd like to demonstrate to you is that in the optimization space, it's a very diverse space. There's lots of solvers, there's different technologies, tools, and an interesting thing about it is that it seems to be diversifying more over time. There's an exciting and very cool amount of work going into both commercial and open source optimization, which is making this a broader space. And that can be a little overwhelming if you think about it from the perspective of like, well, how do I choose what to do, and how do I get these models into environments and use them in a meaningful manner? But the cool thing is that doesn't necessarily mean more cognitive overhead from an infrastructure or management perspective. If we have the right tooling and the right approach to sort of engineering our decision models as engineered objects, then we can unify our approach to testing and managing them and putting them into production. And so that's part of why we're showing these sort of 3 completely different models that do different things with different underlying technologies. We'll be using Google OR tools to do a forecasting model, which may not be familiar to some of you. That's not a use case you see very often with that. I think it's kind of interesting. We'll be using the Hy's integer programming solver to do shift scheduling, and then we'll be using our own Next Move Solver to do routing. And the underlying approach there is heuristic based. And the interesting thing is here, you could apply these kinds of technologies or techniques to really any of these models. So we'll see a little bit about that. So what do these models take as inputs? Where do they live in our operations? So we'll start with forecasting. So the basic concept here is I have some demand that I've seen in the past, and I want to predict what demand will be in the future, so that I can plan appropriately. And this is frequently a tactical model, which you might do days or weeks or even months in advance, because you need to figure out when people are going to work, or maybe even where do you operate? What region does your business exist in? So from that forecast, we're going to have expected demand in the future, unrealized demand, and we're going to have targets. And now targets would be something that you determine as a business. So these might be something like, I want to staff roughly so that I have 5 orders for every driver hour. These things come typically from like the P&L or the business side, where they're saying like, this is how much it costs to operate, and how can I maintain good service levels, as well as make sure that we're solvent as a business. Those things, as well as worker availability, will be the inputs into our shift scheduling. So shift scheduling will, in this case, be a downstream model that takes targets, forecasted information, and manual inputs from workers, and then creates optimized schedules. From that, and that's also a tactical model, which you might do, say, probably days or weeks in advance. And from there, we're going to go into a more real-time model, which might be done in seconds or minutes or hours in advance, where we're going to take available drivers on the ground and actual demand in real time, and we're going to plan routes. So that's what we'll be doing in today's talk. So with all of that said, let's go into our speed run. So I'll go over to my Visual Studio Code. So we're starting with forecasting. And as I mentioned, we're going to be doing this first with a tool called OR Tools. This is an open source library for optimization, which supports a number of different optimization technologies. It has constraint programming combined with satisfiability, and it also has linear programming and mixed programming interfaces. We're going to be using the linear programming interface. And what you can see here is some synthetic data that I've constructed to represent what might be demand for an on-demand delivery platform. This is synthetic, but it has a lot of properties that I've seen in these places in the past. It's very, very spiky from one day to the next. There is an overall trend. So let's say we're operating a region that's growing. So there's an overall growth trend. There's also seasonality, and it's a little hard to look at it and sort of separate out what's going on. Now, in our scheduling model, the way we want to run our operations is we want to schedule by time of day, and we think about those times in basically 4-hour blocks. So what I've done is I've split that historical data, synthetic historical data, into morning, which is the bottom, midday, which is this green here, evening, and then night. And so our 2 lower volume periods are morning and night, and that's fairly typical. And then midday and evening would be our high volume periods. Again, it's still pretty spiky, and it's got this, going from one day to the next, there's pretty big differences. If we look at just recent history, so this is the last 4 weeks of observed data. Again, we see these big splits, but it's a little bit hard to sort of separate out what's going on. And the funny thing here is this is synthetic data, so I know exactly what the features are. But even then, there's a lot of variability, and this is fairly typical for what you'd see in an on-demand platform. So what we'd like to do now is run a regression model against this, and that's one model that you could use for forecast. There's a lot of other ones. We're just going to use this technique called least absolute deviations, or LAD regression. And the first question you might ask is, well, why LAD regression? I like LAD regression because it is robust to outliers in the data. And it's also, I think, an underused type of regression. So the most common forecasting or regression model that you've probably seen is what's called least squares. And in least squares, what we essentially are doing is squaring the residuals or squaring the errors and trying to minimize the sum of those squares. And so if you see here, let's say we've got a prediction line. This is our fitted curve. And then our blue dots are the actual observed data. These little lines would be essentially the residuals or the errors. In least squares, the objective value for the optimization under least squares is trying to minimize the sum of those squares. So really what it's giving us is a situation in which the longer or larger residuals have an outsized impact on the eventual fit. Lat regression is a little bit different in that it doesn't square them, it just sums them up. And so we can see the difference here is that the longer or bigger residuals are proportional in their impact on the eventual fit. And I think that lat regression is actually used a lot less because it doesn't have a nice closed form solution in the mathematics. And so it's an opportunity for us to use something like linear programming. And so that's what we're going to do with OR tools. All right. So the next thing let's look at is just the model behind this. So you can see this is just a simple OR tools Python model. I initialized it using the NextMove SDK. And it's got some data that it pulls in. And then what it does is it constructs a simple linear programming model. So here I create continuous variables, which are the coefficients for the features in my model, in my regression model. So I've got an offset, I've got a daily trend, I've got weekly trends, so on and so forth. This is actually pulled right from a paper by Robert van der Bij called Local Warming, which is a very interesting paper if you want to take a look at that. And so we create a continuous variable for each one of those coefficients in the eventual model. And then what we do is for every observation, we add a variable, which is the fitted predicted model value for that observation, and then a variable for the residual. And the key part here is that the residual is greater than or equal to the absolute value of the observed minus the fitted. And so that's where the linear constraints come in. We minimize the sum of those residuals, and then we use that to forecast into the future. All right, so from an infrastructure perspective, I just got my main.py here, which is what I showed you. And I'm just going to push this into a NextMove app. We'll look at the cloud part of this in a little bit, but right now I'm just going to show you the command line. And so we're pushing this in, and it's going to package it up. And that was very fast, but you can see that it uploaded it to NextMove Cloud, and then it gave me a little advice about how to run it if I want to do so. So I'm going to follow that advice, and what I'm next going to do is pass it this input file. And so this input file is nothing more than for every day, what time of day was it? Was it one of those 4 blocks? And how much observed demand was there? So it's just day by day, 4 observations per day. And that's all the input that goes to this regression model. And I'm going to run that, in this case, using curl. There's a few different ways to do this. So I'm going to demonstrate different ways to do that. Right now, we're just hitting an endpoint, and then I get back a run ID. And so this is now running in the cloud. That was all I had to do to go from local to remote experience. All right, so let's go back here. And we'll look at what's in the output of this forecasting model. Looked like this, again, was the input. So it's just demand data. And then if what I actually wanted to look at was the forecast. Here we go. JSON, okay. And this is the output. And so we can see here, I've got daily data coming back from it. What date was it? Which block of the day was it? What was the observed demand? And then I've got a forecasted value. And so this is what it's trying to minimize. And if I look at the end of the data, I can see that there's some statistics around the actual execution, and I can see it's giving me new information. It's not yet December 10, so this is forecasted data going into the future using that OR tools linear programming model. If I now plot that, what I can see here is those same by time of day plots where we have observations and forecasts. So the orange are the observations, and the lines are the residuals, the errors. And then I can see it's going out into the future and sort of giving me estimated demand in the future. And in this particular model, since I know what goes into it, it was seasonal trends, monthly trends and daily offsets as well as weekly. And so you can see that really breaking down. So it's kind of cool. We can use linear programming to do forecasting. And one of the reasons you might want to do this is because it gives you just a lot more control over the optimization. You can do things like epsilon insensitivity. You can use a mixed integer programming solver and do robust regression. But it's not the only option. There's lots of other forecasting models that you could use in place. All right, so at this point we have our forecast. Let's move downstream a little bit and go into shift scheduling. The other thing that I need to do in order to do shift scheduling is I need my economic targets. So how many, if I have projected demand, how many drivers do I want to cover that projected demand during a particular time frame? And I'm just going to arbitrarily say that during morning and night, I want to meet or be close to roughly 3 orders per driver hour. And that during midday, I want that to be 4, in the evening, 5. And this is a fairly typical thing to do in an on-demand delivery platform, because during low volume, you're probably going to overstaff to keep service levels high. And then when you have high volume, you can consolidate more onto your drivers and you can operate more efficiently. And so we're going to essentially make those our targets into our scheduling model. And so what we do is we take those targets, and then we take our known worker availability. So this is, again, synthetic data that I've generated. And this is for a particular day. So for December 5, we have forecasted demand data. We've got our targets. And then we have all of our drivers with names like yawning lemur or cantankerous chinchilla or enigmatic toucan, who knows who named these people, telling us when they can work, right? And so we match that up with the required workers, which is the output of the forecast and the targets. And now we're going to hand that into our scheduling model. Okay, so for our scheduling model, what we're going to use, and now this is where we're going to go into the Nextmove Cloud part of this, is just a subscription app. So you can see here that we have our Nextmove Shift Scheduling app, and I can just add it to my apps. I've already done that. So I can find it here under Shift Scheduling. You can see here, here's my forecasting. We've got routing models we'll look at in a minute. So under shift scheduling, again, this is using a mixed integer programming solver on the back end, but it could be something else. And we're just going to look at runs, and I'm going to create a new run using this input data. So let's go back here. I've got my worker availability and my requirements. Oops. I'm going to copy that into here. And the first thing that I see is this little user interface telling me what are the blocks that I'm trying to schedule and when are people available. So the vertical blocks here are scheduling blocks when I have demand or workers that I'm trying to schedule. And then the horizontal lines are when people are telling me they're actually available on that day. So let's start that run, and this should be pretty quick. And what it'll come back to me with is an optimized schedule based on coefficients that I give it for undersupply and oversupply, which I'm in control of, and I can change those and rerun. Now I'm looking at this schedule, and let's say that enigmatic toucan comes back to me and says, oops, I have a doctor's appointment. I need to get my beak polished at noon. I can't come in until like 1 p.m. So it's actually fairly easy for me to start a new run and find enigmatic toucan and say, okay, fine. You're not going to start until 1 p.m. And let's just kick that run off again. And what we should see in the output of that, is that it enigmatic toucan. Let's make that noon. Is that the start time is going to be different for toucan if the demo gods are with us. All right, so yeah, here we have different start times for the different people. Okay, and so the output of this scheduling model is essentially a list of when people are going to work based on their availability and the needs of the system. The final downstream piece of this is going to be the routing part. And so this is what's going to happen in real time. And for that, we're going to go back into our apps, and we're going to look at this delivery routing model that's provided by Nextmove. Again, we're going to start here with just a subscription app. And so all I've done is click subscribe to this app in the Nextmove infrastructure. And under the hood, what it's using is a heuristic search with our own solver underneath the hood. And what I'm going to do is I'm not actually going to run this one in real time because it takes about 30 seconds and I don't want to make you wait for that. So this is the Julia Child moment where I take the uncooked souffle, I put it in the oven and I pull the fully cooked souffle out. But everyone likes souffle. So this is an example input and optimized routes where we're doing this delivery in Lancaster, Pennsylvania. And you can see here in the middle, I've got my warehouse where or depot, where I'm actually fulfilling my deliveries from. And then the drivers go on these routes to fulfill demand. You can see I'm only using 5 vehicles. And if you look at the input, there's actually a lot more than that. So let's say I optimize these routes. This might be happening in real time, or it might happen the night before or an hour before, depending on sort of the perishability and the urgency of the requests. And let's say that I'm going to turn all these off and I'm just inspecting individual vehicle routes. Operationally, what I notice here is that these tend to be a little bit long. And so for parcels, for example, that might be fine. That might be perfectly appropriate. But if we're delivering, say, carrot juice, and there's a really short expiration time on that, maybe I want these routes to be shorter or more contained. I might look at this and say, like, yeah, this is probably, efficient, but it's not matching my operations. Can I change that in some way? And so, luckily what we provide is the ability to actually start with a fully customized model from exactly the same starting point as here. So what I've done offline is I've initialized our next route template. And so here is the source code for that template. It's in Go. Some of the other examples were in Python. This was in Go. And I'm just going to add a single line to it, which is telling it to try and cluster my routes as much as it can, just according to this objective. And this is a value that you could play with and see what the output is. I've sort of arbitrarily chosen the value 50. It is a number that sort of weighs it in relation to other things. In order to determine the best value for you, what you'd want to do is sort of use the testing infrastructure that's part of that, but that's a separate Nextmove talk. So I make this one code change, and then I'm going to go into the command line, and I'm going to push this into production. And so we can see it building it. This takes ever so slightly longer because it's actually compiling and pushing it. But now if I go back into my Nextmove cloud environment, I can go to that app, and I created a different app for this. In production, in reality, you might make this a different instance, and this is a custom app, and I can see that I just pushed it, and I'm going to go back to one of these runs, and I can see with the same input, what it's actually doing is it's using more of these vehicles. It is preferring clustered routes to non-clustered. If I turn off all the vehicles and look at them individually, I can see that these are much more sort of centered geographically, and this might be better for my carrot juice deliveries or other perishable goods. We'll look at a couple more. And so these do have a much nicer sort of clustered aspect. Of course, the downside is that now there's more unassigned routes. So with any of these operational changes, there are trade-offs that I need to evaluate. And again, that's something I'd probably do in the testing infrastructure. All right, so that's actually the end of our speed run, and I think we did it just within time. I'll go back into slideshow mode. What just happened here? So we did a few different things. We used OR tools with least absolute deviation regression using historical data to generate a demand forecast. We then used that forecast output as well as targets and worker availability to optimize a schedule for drivers using the Hives Mixed-Integer programming solver. We then used that schedule in real time with observed demand to optimize routes using the Nextmove route solver. And then we changed that model to prefer clustered routes because those were better for our operations. So that's what we did. And what do we want to take away from this? Well, one is, distinct logistics models, they can be created, linked together, and sort of play nicely with each other in a unified platform. Optimization is a very, very diverse world. There's lots of different things. And if you think of optimization broadly like I do, things like forecasting and heuristics also live within that domain. And so part of the art of optimization is figuring out what technology or what technique to use to solve your problem. But that does not necessarily translate to an exponential growth in cognitive load. With the right platforms, we can unify all of these different pieces and we can switch between technologies and sort of embrace this diversification of the field, which I think is really cool. Lastly, you can use OR tools to do forecasting. So it's not a very common use case, and I just thought that was neat. So those are our takeaways. Hopefully you enjoyed the demo.
Nicely done, Ryan. I think you spun all the plates and juggled all the flaming torches nicely here. So thank you. There are a couple questions that came in while folks were watching here. And I think the first one that I wanted to be able to highlight came in earlier on when you were showing the forecasting part. And the question here is, was each series generated as a random walk or uniformly within a range?
Yeah, so the way that I generated this was I generated the sort of the perfect data, i.e., I pre-selected features because I wanted it to look a certain way. And I put a LinkedIn post about this the other day where it was like, oh my gosh, this was hard. I wanted it to not be data that we got from a previous experience because it needed to be fake, but I wanted it to look a certain way. So I knew what was going in and I generated what would be like the perfect data, and then I essentially added noise to it. And I added more and more noise to make it sort of match my expectations of what I've seen in the field.
Excellent. I think also earlier on in your presentation, so I think right when you were transitioning from the forecasting side into the scheduling side, you highlighted or at least briefly flashed a screen that showed a couple of different forecasting models. I think there was a follow-up question there that basically said, are there different forecasting models that could be used within NextMove?
Yeah, and in full transparency, we're actively building out integrations with different kinds of solvers and technologies. So some of the ones that we might want to support we don't have in the platform yet, but it's fairly easy for us to add those kinds of things as people need them. But yeah, some of the ones that we've used in the past include things like Meta's Prophet, Ceramax models, and gradient boosting and decision trees and things like that.
Excellent. All right, looks like there's a question in the chat here from Andreas around which heuristic method is the routing based on?
Yeah, underneath the hood, and I feel like there's another talk in here on this, but then I know there's some content we can share out. Underneath the hood, it's an adaptive large neighborhood search style heuristic with sort of NextMove special characteristics built into it.
Excellent. I'm looking forward to that tech talk. I think it's cool. I think one more question here that came in through the Q&A. Do you use fastest paths pre-computed matrix for the route optimization process? So that seems fairly related to what you were just answering here.
We do. There's a couple answers to that. One is we provide a concept called a measure, and so you can do things like directly embed a distance matrix with just quantities, and those could sort of come from anywhere. And if that matrix gets too large to handle, or you just don't want to generate it, you can also sort of estimate them on the fly using this concept of a measure. So there's a few different paths to estimating time or distance, and it really just depends on how much accuracy do you need, and how is that actually going to impact the decision making of the routing model.
Excellent. I'm going to try and squeeze two more questions in before we wrap up here. And this one might warrant a longer conversation, Ryan, and maybe something that we can follow up directly over email. But there's a question here around LAD, comparing LAD and ARIMA as far as efficiency is concerned. Do you have anything to share on that right now, or we can also follow up?
I'm not a, yeah, I learned forecasting and regression in relation to optimization, and I'm not really I'm not a real statistician or data scientist. That's what I have Nicole for. So I can't really speak as well to that. I can say from I guess if you're asking about computational efficiency, linear programming is efficient. And it would kind of depend on if you're thinking about efficiency from like a generalization perspective, it depends on the data, right? We have seen a in previous experiences that frequently a diversity of forecasting technologies can be required to operate efficiently in different places. So forecasting tends to not be a sort of a one size fits all, right? I've been in environments where we're using ARIMA in certain areas, and we're using regression in other areas, and we're using decision trees in others.
Excellent. All right, we're just over time. I know that there's a question or two still lingering, and I'm gonna, for those of you that asked those, we'll make sure to follow up with you directly over email. Again, if anybody would like to reach out to us or keep the conversation going, feel free to check out our website and send us a message. We'd be more than happy to keep chatting there. So I think, Ryan, if you flip to the next slide, there's two things to just highlight for folks. We shipped our 1.0 version of Nextmove this morning. It's very exciting. We hope folks will try it out. You can experience many of all the good things that Ryan showed you today through the 1.0 kind of unified platform experience. So we hope folks will try it out. Give us your feedback. We're particularly excited and proud of it, and very grateful to everybody, Nextmove team, customers, community members, partners, and alike for making this a reality. So anyhow, we're celebrating that today. It just happened to work out this way. So it was a nice opportunity to share that with everyone. And then on the next slide here, I think, Ryan, the next talk that's coming up will be on operationalizing OR tools MIP models in Python. It will be presented by the fantastic Marius, who presented a couple of weeks ago, actually, on a similar topic, but we'll be looking at MIP this time instead of CP. That'll be Tuesday, December 5th. You can register on our site by going to nextmv.io. And I think that's all we have time for today. We're going to wrap it up. Again, thank you so much for Ryan for the presentation today. Thank you everyone for joining. Until next time.